Why are quadratic equation roots so crucial in algebra? Imagine trying to find the exact points where a roller coaster track touches the ground. Those points are like the roots of a quadratic equation. They tell us where the graph crosses the x-axis. Roots are the solutions that make the quadratic expression equal to 0. Without knowing these solutions, understanding how the graph behaves becomes much harder. A quadratic equation is a polynomial of degree 2, written as x squared plus bx plus c equals 0. Here, a b and c are numbers and it is not 0. The roots are the values of that satisfy this equation. When you substitute these roots back into the equation, it equals 0. That's why roots are so important. They are the exact solutions to the problem. Think of the roots as clues to the shape of the graph. If the roots are real numbers, the graph crosses the x-axis at those points. If the roots are complex, the graph does not touch the x-axis at all. The discriminant, which is b squared minus 4 times a times c, helps us figure out the nature of the roots. If the discriminant is positive, there are 2 different real roots. If it is 0, there is just one real root, which is repeated. If it is negative, the roots are complex numbers that come in conjugate pairs. Finding roots can be done in different ways. You can factor the quadratic, complete the square, or use the quadratic formula. Each method helps you see the roots from a different angle and builds your algebra skills. The roots also have a special relationship with the coefficients. The sum of the roots equals negative b divided by a, and the product equals c divided by a. This means you can actually reconstruct the quadratic if you know its roots. Roots are used in many real-life situations. For example, in physics, they help describe the path of a projectile. In economics, roots can show when profit reaches 0. Knowing how to find and interpret roots allows you to solve these practical problems easily. In short, roots are the key to understanding quadratic equations. They connect the algebraic solutions to the graph's shape and help you predict how the quadratic function behaves. Learning about roots makes algebra more clear and helps you solve many different kinds of problems with confidence.